In this video, we're going to be looking at another circle theorem, the one where two tangents, these two, originating at the same point outside of a circle, this point here, are of equal length. Now, what do we mean when we say that the tangents are the same length? Let's reconstruct the setup to show exactly what I mean. We'll start off with a point outside of the circle, and we'll label that point A. Now we'll draw one tangent line from this point to the circle's edge. And then from the same point, we'll draw a second tangent line in another direction and make sure it also touches the circle's edge. When we say the tangents are of equal length, we mean that for both tangents, the distance between the external point and the point where the tangent touches the circle is equal. In this video, we're going to show why this must be true for any two tangents originating at any point outside of a circle. We'll need to know where the center of the circle is for this, so I've marked it with this green dot. I'm going to draw a radius which goes from the center of the circle to the edge of the circle at the point where the tangent touches the circle. Let me show you where that point is. So the tangent touches the circle at this point. Let's draw the radius between the center and that point. We repeat these steps again, this time drawing a radius from the center of the circle to that point where the tangent touches the circle. I'm going to draw a chord between the end of radius 1 and the end of radius 2 to create a triangle. Actually, I just realized that I need to remove these two lines across the tangents because we don't actually know yet for sure that these are the same length. That's what we're trying to prove, so let's remove them for now. And we can bring them back later once we prove that it is true that they're the same length. Now, because the chord going to the top tangent from center is a radius, and the chord going from center to the bottom tangent is a radius, their lengths are the same. So we have a triangle where two sides are the same. The triangle inside the circle is an isosceles triangle. Let's mark radius 1 and radius 2 to indicate that they are the same length. But before we do anything with this isosceles triangle, I'm going to remove the base of the triangle and the 2 points marking where the tangents touch the circle. And the reason why I want to do this is because I want to figure out the angles at the circumference of the circle. And to do this, we're going to use our knowledge of another more simple circle theorem. And this is the theorem we're talking about. The angle between tangent and radius is 90 degrees. If we take a circle and then draw a line from the center to the edge, that's the radius. Now, if we draw a tangent line to the circle, which makes contact with the radius, this creates an angle between the radius and the tangent, and this angle must always be 90 degrees. The angle between tangent and radius is 90. Now let's look back at the two tangents that we drew earlier. You can see that each tangent is making contact with the radius. The top tangent makes contact with the top radius. So the angle between the radius and the tangent here is 90 degrees. And the same is true for the bottom tangent. It makes contact with the bottom radius, so the angle between the radius and the tangent must be 90 degrees. So each angle is a right angle. Now let's add back in the base of the triangle that's inside the circle. This splits each of the angles at the circumference into two distinct parts. The part that belongs to the triangle that's inside the circle and the part that's outside of the triangle. But since this is an isosceles triangle, we know that its base angles must be equal to each other. Let's give those base angles the label x. Now we know that the entire angle is 90 degrees, but the angle inside the isosceles triangles is x. So the remainder must be 90 degrees minus x. And that's what this angle is, 90 minus x. But we have exactly the same scenario on the bottom. The entire angle is 90 degrees, but the part of the angle that's inside the isosceles triangle is x. So the remainder must be 90 minus x. But the ends of the base of the isosceles triangles are in contact with this radius, the top radius, and the bottom radius. So the base of the isosceles triangle must also be in contact with the two tangents. And so what we have is a triangle where the two sides are the tangents to the circle. And if you look at the base angles, they're both 90 minus x. The bases are of equal value. And we know that if a triangle has two base angles that are equivalent, it must be an isosceles triangle, which means that the two edges that are not the base are equivalent in length, and that means that our two tangents are the same length. And so we've proved the theorem that two tangents originating at the same point outside of a circle are of equal length.